here is what? This is 3 plus epsilon. This is 3 minus epsilon, right? 1 is the greatest distance we'll allow 3 to be away from our function, right? So the function can only be these values in here right now. These in here. That's all the function values we allow. If we're going to bound the distance between 3 and our function by the number 1, right? So that's what it sets up here. 3 plus epsilon and 3 minus epsilon, right? So the distance here is epsilon in both cases. It depends whether you're subtracting or adding. So I'm using regular ease, sorry. There, okay? That's that error distance. How far will you allow your function away from 3? A distance 1 right now. Oh, you want to pick number 1 for delta? Is that what you're saying?
0.5.
0.5?
Can you just pick a whole number?
2. I hear 2, I hear 1, I hear 0.5.
I thought you wanted smaller.
It is 2? Sarita, you seem pretty confident. 2?
I don't know.
Well, I'll tell you, on this picture, it shouldn't be that hard to figure out. What this says is, how far can x be away from 2? How far can x be away from 2 to make sure your function is only this far away from 3? Well, if you think about your picture, this linear function, try another color, but whatever. The distance away from 2 can't be more than 1, right? That's all right here. But 0.5 would work just as well. It's not specific to 1. There's not only 1 delta in all these cases. 1 is the largest delta you could have right now. Okay? Why is that? Because here, what is the number 3? Just like the number 4 here is 3 plus epsilon, the number 3 here is 2 plus the delta we're going to choose. We choose delta to be 1 in this case. Okay? And this is 2 minus delta. So this distance here, delta is the error we allow, it's not really an error, but it's the error we allow x to be away from what it's heading towards. So in this case, we're only allowing a distance of 1. So this is a delta distance, and this is a delta distance here. Okay? 2 plus delta, 2 minus delta, a delta on each side is what it's referring to. So let's show that it's true though. I'm saying it's true from the picture. It seems reasonable. As long as I contain the x's to be only a distance 1 away from 2, I will have contained the function values to be a distance 1 away from 3. Does that make any sense? That last part needs to make sense.
A distance 1 away from 3?
According to Sarati's second choice, Chan's first choice, as long as we contain x and 2 to be a distance 1 from each other, right? We're only going to allow x to be a distance 1 away from 2 at most. So that's everything between 1 and 3. So as long as x is only between 1 and 3 here, a distance 1 away from 2, that is going to guarantee that the function values, right, the heights, are only a distance 1 at most away from that location called 3. This will guarantee this always. From the picture, we haven't proved it yet, but from the picture it seems reasonable based on the fact it's a linear function and we can just draw this little line straight down. Okay?
We said beta equals 1, right?
Delta?
Delta equals 1.
We're choosing delta to be 1. If you should choose delta to be 0.5, and you would constrict this a little bit further, it would guarantee you the same thing.
What?
Your function values would still be, right, between 2 and 4. They're more contained, but that's fine. They can be more contained.
No, since it has to be less than, not less than or equal to.
They did it.
How is it
The
more?
writing
X can't be same.
Delta is 1.
I don't know. Delta
X
is
minus 2. The distance between x and 2. Do you guys know what this means? I don't think you guys know what this means. These symbols mean distance between, in this case, x and 2. You're used to reading it as some sort of absolute value, and it is an absolute value. But it means distance between 2 objects. This is the distance between 2 things. Something minus something in an absolute value means distance between them. That's what it means. Just like here, this is the distance between the function and 3. Before I lose you completely, we're going to prove that Sarati's guess and Chan's guess works without the picture. Okay? So if we say, let delta equal 1, then x minus 2 is less than 1. We're going to force that to happen. And we believe it will guarantee this. We need to show that it's going to guarantee this. Okay? You with me on that? You're not with me. Speak up then. Tell me what you don't get. Give me something to repeat. Come on. Something to say new. Okay, I'm going to keep going then.
Wait, okay,
Justin,
so-
too slow. You didn't. Come
Okay,
on.
so can you just repeat the last part? Cause the very last part you just did.
This part here?
Yeah.
We're going to pick delta to be the number 1.
Okay. And we're just assuming delta is 1.
Yes, for the moment.
Okay.
And we're going to show that as long as delta is 1, then the distance between x and 2, right, being only at most 1, right? You can only extend away from 2 at distance 1 in either direction.
Okay.
So this says here, x is trapped between 1 and 3. That's what we're going to show it in 1 second, algebraically. That's what this says. This says x is trapped between 1 and 3. That's what this statement says. You see from the picture how it must be?
Yeah.
Okay. That's going to guarantee that our function, which is x plus 1, and this number are only a distance 1 away from each other at most. They can be no further away from each other than 1. This is going to lead us to this. As long as delta is 1, then this function is this close to 3, for sure. That's what this is saying, right? This is distance between function and 3. So as long as we say this is x, that means these are the possible y values.
So we're trying to prove that the distance between f and 3 is 1 or is less than 1?
Yeah.
Okay.
Because Roselle's picked a particular value for epsilon right now. We've chosen a particular value for epsilon.
Okay.
Right? So if x minus 2, the absolute value thereof, is less than 1, what does this mean? To remove the absolute value symbols, you write x minus 2 less than 1, but it's greater than negative 1. Right? That's what an absolute value inequality is written as, without the absolute values. They say the exact same thing. Do you agree?
Yeah.
You guys remember that from? All right. So now, what do I have here? I have the function x plus 1. I want this to lead me to say something about the function x plus 1 and its relationship to negative 3. So, is there a way that I could change this to the function x plus 1? How would I change x minus 2 to x plus 1? What's that? I could plus 3. If I plus 3 this whole thing, the inequalities remain the same, correct? I would have 2 less than x plus 1 less than 4. Is that correct?
And the distance doesn't change between them.
I thought this is being this thing.
What's that?
Never mind.
Okay. Now, I would like to say something about x plus 1 minus 3, right? This function here is x plus 1. So now I have f of x here. I have 2 less than f of x less than 4. So now I need to subtract 3. Okay? And I'll have the form I'm looking for. So subtract 3, negative 1